So we've been talking about direct variation and inverse variation all day long today. Well, maybe not all day long. But direct variation is when one quantity increases proportionally to another quantity, right? And inverse variation when one quantity decreases proportionally to another quantity. So we've been looking at some examples. We've looked at the Hyunjun's cookie stack examples. And now we're looking at some questions, or I would say some data that they have in our workbook. So we are going to actually start out with question number 2 because that seems a little bit more straightforward. So let's take a look. Conservation. A school is raising money to donate to a rainforest conservation group. The table gives the cost Y in dollars to preserve X acres of rainforest. And if you take a look at our X values, they're going up. And what about Y values? We go from 60 to 180 to 300, right? So since as our X values are going up, our Y values are also going up, we know that this is a direct variation, right? Now they want us to find the constant of variation. Constant of variation is simply the rate or the ratio, right? Rate if the units are different, and ratio if the units are the same. And in this case, our units are different because we have amount of acres and we have cost. So we just have to find the rate. How do I do that? Well, we can go ahead, rewrite our data like so. I'm gonna write it from here. I can rewrite it like 1 to 60, 3 to 180, 5 to 300. Okay, I just wrote the very first 3 data values, and I put them in ratio forms, and now I'm going to put them in fraction because fraction is just another way of expressing ratio, right? So I'm going to have, and over here, what we need to pay attention to is the fact that they want us to consider the relationship between Y and X, as in the table gives a cost Y in dollars to preserve X acres of rainforest. So that means for 1 acre of rainforest, we don't know how much it costs, but that it's going to cost us $60 in total, right? So what we have to do is 60 divided by 1. So therefore, it's $60 per acre, right? And if we take a look at our very last ratio, now I have amount of acres first, and then that's compared to the cost. But since we know that 1 acre costs $60, we can rewrite this as 300 to 5, which is 300 over 5, which is 60 over 1. So we have equivalent ratio, right? So my constant of variation is 60. So now, when they want us to interpret it for the situation, what they want us to do is just literally put this number in the context of the scenario that's been given to us. And this simply means that, hey, 1 acre costs $60, right? So now we can use this value to go ahead find out how much it's going to cost us in order for us to buy 14 acres of land. So it will go $14 times 60 equals y, right? 14 times 60 equals y, and that's going to be $840. That's going to be the cost of y. Fairly simple, right? Let's try now number 3. So this was for number 2, conservation. Now, number 3 is all about fundraiser. The school band is selling tickets to its annual fundraiser. The table gives the money raised from selling tickets y in terms of x, the number of tickets sold. So in this case, whoa, big thud. Okay. Our y is money raised and x being the number of tickets sold. So if we take a look at our x values are increasing. So we go from 18 to 20 to 26 to 30, and the money raised in dollars actually goes up as well, from 252 to 308 to 364. So let's once again put them in ratio. So I went ahead this time around, put my y values first, since I want to know how much one ticket costs, right? Yes. So not how much one ticket, well, we would have to find out how much one ticket costs for us to find the constant of variation. So as you can see, this is direct variation, as I reiterate one more time. And now let's go ahead and see. So 252 to 18 can be expressed as 252 over 18, which can be simplified to 1, 2, 6, 9, and 126 over 9 is 14. Let's see. So if I do, when I do 252, 252 over 18, I can simplify that to 126 over 9, which is 14. Now let's double check with another number. I'm gonna take a look at 364 to 26. 364 over 26 can be simplified to 1 and 104, so 14. So now we know that the amount of the cost for one ticket is $14, right? $14, and that's also my constant of variation. So that means if I want to find the value of y, all I have to do is y equals 48 times 14. And that's going to give me the total amount of money raised when when 48 tickets are sold. So that's going to be y equals 672. $672. All right. So 2 and 3 were fairly easy peasy. Now let's take a look at question number 4, driving. The table shows the distance y that a car can be driven at a constant speed using X gallons of gas. Actually, I want you to try question 4 on your own because, once again, this is direct variation. So using the methods that we've used so far, I want you to go ahead, find the constant of variation, and ultimately determine the missing value of y. I want us to take a look